Hi, and welcome to all human beings and machines that tuned into our Code With Us session this 6th of September 2021. I am Tobias Schwarz, Ecosystem Development Engineer at Tendermint, and with me I have Aliaska Merchant, who will present you the walkthrough. Today we have a special topic to cover, which will be very useful for service creators and developers who build on top of a Cosmos SDK blockchain. If you love creating services, bots, helper tools, frameworks, or just love working on code, you have come to the right place. Today we will cover how to create a blockchain with Starboard and work with messages and transactions in Go. So with the Cosmos SDK, as you probably know, you can develop modules that define your application state. In this session, we will teach you how to create transactions that alter the transaction state with Go. Be aware, we are early, so this feature we are presenting in Starboard will be available in the next, soon-to-come Starboard version. And with this, I'm giving the stage to Ali, and thanks for being here. You want to say a word about yourself?
Yep. Thank you, Tobias, for the kind introduction. So yeah, my name is Ali, and I work with the EcoDev team here at Tendermint, and we will be today looking into, most likely looking into how to create a blockchain using an independent application, and that's going to be the goal of today's workshop.
I'm great. I'm looking forward to this because I'm actually myself. I love working on services or bots. I've developed several bots already with Cosmos blockchain and had to use other tools. And I'm really looking forward that this feature now comes to Starboard and will help us in building these kind of services. So really looking forward to your demo.
Sure, awesome. So yeah, I think let's get started. I will quickly start off by presenting my screen.
All right.
Uh, is it visible now?
Mm-hmm.
Okay, cool. So I have two applications open. One is the terminal and one is the VS Code for the sake of convenience. So before we start talking about what it is, so just like a quick introduction. So basically we will be using Starboard, which is a wonderful tool for scaffolding blockchains and giving you that skeleton to work upon. And then once we scaffold a blockchain, we will run the blockchain, and then we will create a Go application that will connect to the blockchain. Now, um, so the first thing I want to start off with is scaffolding a new blockchain. So I will use the Starboard command, Starboard scaffold chain, and then I'll call my blockchain blog. So this basically scaffolds the new blockchain called blog, and it gives me all the different codes that I would want to build my chain upon. Also, this is my GitHub address, so I'm using my GitHub address. You could use your own GitHub address, or you could use just an example, or whatever you suits you. We'll give this a second, while this scaffolds. Um, Okay, so awesome. So we have a new blockchain called block scaffolded, and then we can start the blockchain right away. So actually, before starting the blockchain, I will do one more thing. So I'm going to create a scaffold, something called as list. So what is a list? List is a data type which gives you the ability to perform CRUD operations. So you can perform create, read, update, delete operations on a given data type, which in this case will be a post. So post is the name of the list that I've created, and the title and body are the fields of that particular data type. And if you're wondering, this S is a shortcut you could use. So instead of writing the whole term scaffold, you can write S, which conveniently lets you scaffold a chain. So meanwhile, I'll actually just create a new tab. So let me Okay, so what I'm going to do is I'm going to start the chain. So I'm going to say Starboard chain serve, and then I'm going to use the reset flag because I already have an instance of this particular chain running. So you could use serve by itself if you don't want to reset the instance of it. Uh, I'm also going to throw in like a bonus out here. So I'll just give this a second for this to build. Um, so while this is building, actually, we can like start off with creating our skeleton. So right now we are inside the blockchain. Now the goal is to create an application outside the blockchain which will connect to the blockchain. So let me just like go outside the directory of the blockchain, and I have a client folder which will consist of the code that I will write on the client side to connect to the blockchain. Okay, so this is good. We have a blockchain up and running. We have two accounts created called Alice and Bob, which we will use to interact with the blockchain. Also, like I'm throwing in like a small bonus here. So I'm going to use this utility tool called Jex, which basically gives you the capability to see the latest confirmed transactions and the block height and all the different awesome things. And we will get back to this like once we perform some operations and then we want to verify the transaction. So yes, so as we get back on the client side, so we have done like two things. We have scaffolded a new blockchain, and we are running the blockchain. Now our goal is to create a Go application that will connect to the blockchain that we're trying to run. So let's create a new Go file called main.go, and we have it here in the client running. So this is something which we will like code from scratch, like how we would want to build and connect it. So let's do some housekeeping work first. So let's quickly import a few things that we will need. So we will need context, we will need fmt and log. Okay, so now we need packages, different packages that we would use for our particular instance. So the first thing that I'm going to include is blog types. Now, if you would have paid attention to the scaffolding that I did, I scaffolded on my own GitHub. So I will be using the same address because I want to use the packages that is being provided by the chain. So this is one of it. Uh, I can. So this is one package, and then another package we need is from the family of Starboard. So we need a package called Cosmos Client. Now, if you are wondering what Cosmos Client is, this is a package that will be released in the upcoming versions of the Starboard. Now, this allows you to connect to the blockchain via RPC. So it is making an RPC connection under the hood for the chain. So I think yeah, we just need like these packages, and yep, we are pretty much done. So we can like start jump. We can like jump into the actual coding itself. So let's start off with writing the main function. So before we write the main function, let us take a step back and think like what are the different functions, or what are the different areas that we would like possibly like to code. So the first thing would be obviously like to create a connection between the chain, and for which we will be using Cosmos client. uh, that's the first thing. Second thing is we would want to create and use an account name. So what is this account name? So whenever you're trying to interact with the blockchain, we would need a user account who would be the account that signs the transaction, broadcasts the transaction, and has the capability to do all those things. So if you remember, when we started the blockchain, we had Alice and Bob as two accounts by default given to us, and we will be making use of Alice to connect to the blockchain. So the second thing that we are interested in is creating a new user account, creating that account name, and fetching that address from the blockchain. The third thing is we want to create a post. So since we are dealing with a blog tutorial, we have CRUD operations on blog. So we can create a post, we can update a post, we can delete a post. So the first thing for this example, we will be creating a post, and then once we have created the post, we will broadcast it, and then display it. So don't get too worked up if you are like not understanding what broadcast and displays and how it works. We will like try to tap into each section like in a little more detail, like as and when we reach to that point. So yes, this should be the entire structure of the code. Like this is the way we are trying to code. So let's start off with the first thing, which is creating a new connection. So for this, we will be using Cosmos client to make a connection. So Cosmos client gives you a very good capability of creating a new connection. So Cosmos is the variable that I'm going to use to define the connection, and I'm also going. It also needs to handle error, so I will use an error variable as well. Let's quickly handle this error. Let's say so. Basically, whenever some error is being thrown, I am just going to display that error. That's the only thing that I'm doing right now. So, and if you're wondering what context or background is, that's a Go routine that tells your function to run in the routine or run in the background while your main function is trying to fetch the API from the blockchain. Kind of like a very handy thing that Go provides. Okay, so this should be it. This should help us like create that connection and like establish the the thing we want. Now, the second thing that we are particularly interested in is creating and using the account name. So as I've been iterating, we are using Alice. So let's call our account name as Alice. Oops, typo. Okay, so Alice. Now, the blockchain or the program by itself wouldn't know what Alice is. So the obvious thing we would have to do is we would need the address of Alice. So we are going to define the address. So let's say we have address which is coming from Cosmos. Cosmos was like the Cosmos client definition that we just made in the previous step. So this returns the address of the account name that we are passing to it. So in a nutshell, what this would mean is when we're passing Alice as an account name, this would return the address of Alice. So typically, this address of Alice would be returned as an return argument for this particular function. And as we did in the previous step, let us handle the error here. So we are just going to print if there is any error. Now we have successfully completed two important steps of creating a new connection and then creating and using the account name. And this forms like a very, very basic foundation of what we're trying to do. Now the next step is a very specific step which is useful in our example. So creating a post, deleting a post, etc. That's a specific thing that I'm doing to a blockchain. But if you are writing some other blockchain and you have some other application, this would change depending on your use case. So let us start with this part. So in this the first important thing is you need to create a transaction. So let's call it message, and we are going to say and types message create post. Okay. Now, okay, so if you are wondering where this comes from, so if you look under the blockchain directory, so if you look under blog and you look under X and you look under types and you look under messages underscore post, so this was the boilerplate code that we got when we scaffolded a new blockchain. So if you look at message create post, uh, this is the thing that we're trying to access from the blockchain. So it it requires three parameters. One is the creator string, one is the title, and one is the body. So these three parameters have to be passed to this message create post in order to create a new post transaction. So we're going to do that same thing. We are going to pass it three parameters. The first would be creator. So let's pass Alice. Then the next thing would be title. So it would be, let's call it code with us. And oh, okay. And the third thing we need is body. So let's call it, this is a demo by, let's say, Ali. Okay. So these are the three things that we need. Now this is good. This is kind of like handy, but there is a problem to this. The problem is the creator, though I'm calling it Alice, but the application doesn't know like who Alice is. So what I would do instead is, instead of passing Alice, I would pass address. So this makes more sense because address is basically the address of Alice, and for performing any operations, I would need the address. But this itself would throw me an error because this is expecting type string and I'm passing it a type address. So what I'm going to do is I'm just going to like make it two strings so that it gets converted into string. So this is it. This creates a transaction and we should be good. Now, so like just to like go over, we first scaffolded a blockchain and then we created a new list called post, and which had fields called title and body. Once we did that and we had a chain running, we started off with some housekeeping work. So we imported a few things that we needed. Then inside the main function, we have performed three operations till now. So we worked on creating a new connection, we worked on creating a new user account name, and then we have created a post, which is the transaction that we are concerned about. So this marks the end of like the first section, and now the second section is fairly simple. So we just have to broadcast the transaction. So again, like broadcast. So let's say I'm using a new variable called transaction response, short formed into txresp, and let's use Cosmos broadcast. This is broadcast tx. Okay, so Cosmos was again the variable used for with Cosmos client while instantiating Cosmos client. So this also gives the capability to like broadcast a transaction, and then we need to pass in two things out here. One is the account name and one is the message. Okay, so this broadcast transaction is doing a lot of things under the hood in this one line. So let's try to understand this part. So when I'm calling a broadcast transaction, method, it can perform two things. One is, if the transaction is already signed, it can just broadcast the transaction. And if it's an unsigned transaction, it can first sign the transaction and then broadcast the transaction. So if you look carefully, in our case, we created a transaction, but there is no way we are signing the transaction. Correct? So the first thing that the broadcast transaction will do is sign the unsigned transaction. And how does it sign the transaction? It can sign the transaction using the account name, which is basically the address of Alice. So just to show you over here, this is the address which is used to sign the transaction. And then once the transaction is signed, it is then broadcasted. But which transaction is broadcasted? So this transaction, the message that we defined in the previous step, this transaction is broadcasted. Yep, that's it. You just have to like broadcast the transaction. It works by itself. So I'm going to throw in. So we just have to handle the error. So I'm just going to display the error if there is any. Also, let me throw in something extra. So let me actually also print the transaction response. So whenever there is a transaction response, let me move this. Okay, so whenever there is a transaction response, whatever the response is, we will like display it on the screen on our terminal. And the last thing we are concerned with or we are doing is display the output. So for this, we let's create a new variable called query client, and we will be using block types.new query client. Now let's make this first. Okay, so block types is basically nothing but types which we defined over here. So this is the types package which we are getting from our scaffolding, and this has a very good feature called post and post all. This lets you actually display whatever output you had. Okay, so once this new query client is instantiated using this newly created variable query client, I will display the output. So let's call it query response. Let's also handle the error. So let's say okay, let's use query client dot post all. Okay, so let's look into this, like what's happening over here. So query response is the variable that would store the response. So post all is a function by inside the package direct inside the types directory that displays all the different transactions that has taken place. But since we have done only one, or we would be doing only one transaction when we run this, let's actually make it post because we don't want post all. So let's, if we call it post, and instead of saying query all post, let's say query get post request. Okay, so yeah, this is fairly simple. It runs in the background, and this is returning one transaction, like that is the latest transaction that took place. And this is it. This is a fully functioning program that we would need in order to connect to the blockchain and display the output. So let's go ahead and run this. So before we run this, we just need to do a little housekeeping thing. So one of the things that we need is go.mod. Now go.mod defines the packages that we would need for our client application to run. So it's basically importing the blog which I used over here, and it is also using Starboard, which again I defined over here. So I think yeah, we are good. We can.
Maybe you want to add a package on top of the main.go file.
Yes, thank you for that suggestion. So I can say package. Okay. Yep. Okay. So I think we should be good. So let's try to run this. Like hopefully it doesn't throw in any errors. So let's say we say go more tidy. In case you're wondering what go more tidy is, it basically downloads or installs packages that need to be used and deletes the packages that are like not in use. Just tidy, just housekeeping work. Okay, so this is running fairly good. Now let's try to run our application. So we say go run main.go. Okay, once again. So we have um okay, my bad. So we have to like display this as well. So let's say let's actually first handle the error. We didn't complete this part, sorry. So let's handle the error first, and then let's say okay. This makes it easier. Okay, let's try running this. Awesome. So this works. So if you look at the response, this is basically displaying the response from transaction response. So if you look at the response at this particular height inside the blockchain, a new create post was created, and this was created by this address. So this is the address of Alice. You can look at it over here, and the title code with us and body, and this is the demo value. Okay, so this is good. This works fairly well, and if you look at the checks, you can see that the transaction was confirmed over here. So this by itself works well. We are good. So we performed we performed create a post. So that was I think that is the expected output we are trying to get. Let's actually run this one more time just to like see if it works as we expected. So oh boom, it runs again and it displays the same thing that we needed. Now in case you're wondering, we ran the transaction twice, but we are just getting the output once. So we are just seeing like one creator, one title, and one body. This is because we are using post as a method instead of post all. So let us actually say post all instead of post, and let's make this query all post request in order to display all the different posts. So ideally, this should be returning three posts because we are running this for the third time. And yep, it does. So if you look at the total, it says three. So you can just count it by yourself. Like it says you'll have three different transactions, three different outputs. Now, um, this actually brings us to the second part of the section, which is going to be like fairly quick. So I have like three same transactions. So what I'll do is I'll delete the third transaction and I'll update the second transaction. So that will like help us wind up the entire CRUD operation. So first thing I'm going to do is actually comment this part because I don't want to create a new transaction again. So let's comment this part. So now we need two things. One is we need update a post, and then we need delete a post. Uh, this is fairly simple. It's just the use of message update post. So we can actually take this as a base and then try to do this. Now, one additional parameter that message update post needs is ID. So which was missing in case of create a post. So we also need ID. So we are going to pass the ID. So the ID starts with the count of zero. So the first post is zero, and then the second post is one, and so on and so forth. So since I want to update the second post, what I'm going to do is pass the ID as one, and everything remains the same. So instead of saying code with, oh, okay, code with us, I'll let's say code with us part two, and instead of in the body, this is a demo by Ali. Let's call it demo. Let's call it help by. Okay, so we are updating the post. All the previous steps remain the same. So once you have created the new transaction called update post, you have to basically broadcast it and display it. So let's make use of this previously written code, and let's so this is broadcasting the post, and okay, yeah, this is the broadcast part, and delete is like very similar. So all you have to do is create a new message or new transaction, and so let's call it message delete, and then go into types. In case you're wondering where this comes from, so as I mentioned in the start, it comes from like the package type. Inside the package you have types, and then you can see message create post, update post, delete post, etc. So all this comes from here, and message delete post accepts actually two parameters. One is the creator, which is Alice in our case, and then ID. So we are trying to delete the second, I mean third transaction. So we are going to use ID as two, and in a very similar way. Actually, this is a comma here. Okay, and in a very similar way, we are going to like broadcast this transaction. So let's reuse this broadcasting code. This needs to be renamed. This is message delete. So in case if you're lost, like what's being done, I just want to like quickly go over. So we created a new post out here. We created a new message, and then we were like broadcasting it. And within broadcasting, we are performing two operations. This one particular line of code does two things. It signs the unsigned transaction, and it broadcasts the transaction on the blockchain, and then we were just like displaying it. So similarly for update post, we are updating it with the values that we want, and then we are broadcasting it. And for delete the post, we are just passing in the transaction that we want to delete, and then we are broadcasting that particular information on the blockchain. Everything remains the same. So the display all should display all the different things, and we should see that happening on the command line tool as well. So yep, let's try to run this if this works. Okay. Oh, actually, my bad. I did not save the program. Okay, so we're getting two things. So let's look at this. So the first thing, the first response we're getting is for update the post as expected on this particular height, and then the second thing we are doing is delete the post as expected. So if you look at this particular section, this is a demo held by Tobias. So we have successfully updated this, and we have deleted the third thing that we did not want. But we actually, since I did not save the program, it actually ran into once again. So it kind of like created a new transaction as well. So let us actually delete that thing. So I don't want the third to be there. So I'll just say I'll delete this thing. I will comment the rest of the section. So I'll comment update a post, and I will just let the delete post be. Everything remains the same. Awesome, this works. So we are deleting the post, and as you see, we just have like two things remaining. One is this body, and then the second is this body. And just for some bonus, the transaction is confirmed over here, and we can see that thing happening on this particular height. So if you see, delete a post has been confirmed, and update a post has also been confirmed on the transaction. So yep, this marks the end of like trying to connect to the blockchain application and using Go as a language to connect and like talk to the app, to talk to the blockchain. So this is like one use case of it, and there might be like a lot of different use cases that you would want or you would think of, and then once you have that, you can always feel free to like explore the different things that you would want to do. Yep.
Great, thanks a lot, Ali. So let's recap. I'm always still amazed by Starboard. So you've scaffolded a new blockchain from scratch, kind of created a blog like a blogging software on a blockchain, and then a new service that knows and that handles all the messages that you've created. So that's creating a post, updating a post, deleting a post, and that's all in half an hour. So it's insane.
So this is the most amazing thing about Starboard, that you can literally scaffold a blockchain and run the blockchain in like just 5 minutes.
Yeah.
So, yeah, this is like something very powerful that Starboard has done.
So we have a few questions, and I also have a question. So mind sharing your screen again, maybe?
Yeah, sure.
So one question is coming from Crypto Pablo on if we should handle the error on message delete. Can you maybe show that part again?
This part? Are you like talking about this part?
There is no error returned, right? Okay, that's already answered by someone from the community. Great. Another question I had is because the feature is not yet available in the current Starboard release. Do you mind sharing your go.mod file and see how people can access it already now? Yeah. I think one of the members working on Starboard actually has provided kind of a preview demo that you can use already from Ilkay, right?
Yep. So yeah, if you look at the go.mod file, right now I'm using like one of the developers from Starboard. So I'm using his version of Starboard till the function is like merged into the release, the next Starboard release. But once it's done, you would not need this line of code. You would be just using it from Starboard. But till then, yes, you can. If you want to play around with it, you can use the package from here.
Okay, cool. So be aware if you use, so currently we are on 0.17, right? And we are waiting for 0.18 of Starboard for it to be included. And before it's released, we have to use this workaround and replace the repository by the one you're seeing here on screen. Another question by Crypto Pablo is, since we can delete and modify messages, how is the unmutability handled of a blockchain? So my take on this would be that we on Starboard, when you're using this list command and create a new message type, then it comes with the whole CRUD functionality. So you have create, update, and delete. But and this is how the program is being the blockchain is being programmed from the start. So you can decide if you want to have the whole CRUD functionality if you're creating your blockchain. If you want to allow your users to update certain blog posts, which is, I think, for a blog very common that you want to change some content on your blog. It's all being recorded on the blockchain, so each transaction will live on the blockchain as long as the state is not reset. We are in a developer environment here, so we can do whatever we want to the state. But as soon as it's a live blockchain with a distributed validator set and a lot of users, then you will see all the transactions, and they are immutable, but that doesn't mean that you can't change the state of a blog post if it's programmed as in the logic, right? It just means you can't reverse a transaction that has happened, if that clears your question already.
Yep.
All right, and we'll stay here for a bit in case you have any more questions. Yes, every CRUD method will need to pay a gas fee. So the question by Christian is, every CRUD method will need to pay a gas fee, and how does the transaction get signed? So yes, each transaction will need a fee on your blockchain. And the transaction gets signed, I think it's by broadcasting transaction function that you've used, right?
Yep. Yeah, so the new function from like Starboard, which is Cosmos client, gives you this capability of under the hood signing the transaction from the address that you have passed. So in our case, we were passing the address of Alice. So Alice is the one who's signing the transaction. And for our case, we were not defining like what is the maximum gas fee that we want. So it just took max as like the value. But if you are in a live blockchain, you would be like defining what is the maximum gas that you want to spend. So.
And maybe what's a bit the confusing part here is that you didn't pass in a passphrase or any private key in that moment, but it's already recorded on Ali's keychain. So as soon as he has started and served the blockchain, there's two accounts on the keychain added by Starboard. So that's Alice and Bob. You can add more to the keychain by using, in his command, this would be block the keys add and then your name. So that's a typical command for Cosmos SDK blockchain. And this would add it to the keychain and can be used by the app in order to sign transactions.
Yep. So if I like quickly share what this Tobias said. So if you like say blog D keys and then you say list, it actually returns you the list of different addresses you have in your keychain. So you can add a new address if you want. If you want to add, say, Ali as a new chain and then pass in the public key and the address, so you could actually do that. So this would take mnemonic as like one of the fields, and you can set up your own private key in the keychain, and then you can use that to like sign a transaction.
And we have one more question by Soumya. How to estimate the gas fees? Do we need to give fixed values?
I don't think you need to like give a fixed value. You could be giving a variable value. For development purposes, we always use maximum value so that our transactions never fail. But in a real world situation, you would want to give based. So there is like, if I'm not wrong, when you like run the application, it like shows you what is like the gas that might be required. So like an estimation. So you would want to pass in like that amount of gas, a little more than that actually, to.
And to learn more about that, it's also written in the Cosmos SDK docs, so check the docs. And as far as I'm aware, it's by computation amount required by a transaction that the gas fees are computed. And you can, those set still kind of the gas maximum I'm not sure if that's also only recommended for development purposes, because in services that I've written for mainnet, I also do that still because I don't want my transactions to fail. So I'm passing in use the maximum fees as possible, and usually transaction on Cosmos SDK chains are not too expensive.
Yep, that's right. And if you're coming from an Ethereum background, Ethereum charges a lot of gas. So yes, this looks very cheap.
That's the power of the application-specific blockchains, right?
Yep. Agreed.
All right. Any more questions? Use the chat. Oh, Pavel is coming with what recommendations can you make for designing read-heavy clients? I'm not sure what. Is it worth to always query the chain or cache previous transactions? Good question. It so much depends on the application.
Yes, totally. Because read is actually, I don't think read requires any gas. So read is like a free operation. It's not a transaction that's happening. So it's like you're not doing anything on the blockchain. So what I have seen, it totally depends on the application. So if you have an application where you need like real time ready data, so then it's better to like query the chain. But if you are okay with some delayed data, maybe like a few minutes or like maybe an hour or something, that you might want to like use the cache.
And here's another downside when you use the Cosmos SDK right now. So when your blockchain is syncing, you can't read from the blockchain at the same time as it's syncing, actually. So if you really have very heavy clients that have to read from the blockchain, you should either have a couple of nodes ready that you can distribute the reading state to different servers, or, as you said, cache the previous transactions. So both could work. Caching them is probably easier and more maintainable, and also not so infrastructure heavy. So that's, yes, what I would recommend to do. And then your blockchain runs way smoother as well.
Yep. I think that answers the question.
Great. So there's another question by Renato Rocha. Does Starboard enable communication with other Tendermint-based blockchains, or only Cosmos specifically? So I'm taking this, Ali, or do you want to answer that?
Yes. So it does. And I think like IBC is like one of those features that helps you connect with other blockchains. But I'm not sure if I like follow the question correctly. The Starboard enable.
Okay, so I would let's see if I can answer this to your satisfaction, Renato. So yes, we do have IBC to communicate with other Cosmos SDK blockchains, and this is coming with Starboard. So you're safe on all the other Starboard built blockchains. And for other Cosmos SDK blockchains, you'd have to check if they are already on the latest version, which has IBC enabled. And this is from 0.40 going upwards. Then it would they usually have IBC enabled. For Tendermint-based blockchains, this is not natively the case. So you need the IBC module on your blockchain, and specifically in order to make transfers, that's the IBC transfer module. And that's something you can usually check on the GitHub repository if that works out.
Yep.
But yeah, it's all coming natively with Starboard. So as soon as you scaffold with Starboard, you'll have IBC on there.
Makes sense.
Thanks for the emojis. Keep it coming.
Yep.
Okay, let's see if we have more questions. Oh, where you can reach us if you have more questions. So definitely come on the Discord. You'll maybe Daniela is here and can post the link, or else I will quickly look that up for you. We are always available on Discord. Have some patience. Maybe we need a few hours to answer. Usually, though, we are very quick in answering. Here is the link for everyone.
Yeah, Discord is the best way. And if you have, you could also open up issues on GitHub. So if you want to add a new feature, if something doesn't work out for you.
So definitely also try look into Starboard repository to stay up to date. That's on github.com/tendermint/starboard or the Cosmos SDK and github.com/cosmos/cosmos-SDK. And that's where you find the latest tech and stay up to date with reading the change logs and latest releases. Just follow those. Great, perfect. So we, as we're not having any more question coming in, I guess I'll have to thank everyone for attending and for everyone that's here in live, else for everyone that watches the recording on YouTube. And thanks for following, and talk to you in the next Code With Us session.
Thank you guys. Bye.
Thanks. Bye-bye.